بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله وبركاته. Math grade 9 Geometry. We are in Model 3, Lesson 5, Proving Segment Relationships. Proving Segment Relationships. So in this lesson, we want to learn what the meaning of the segment addition. The points on any line or line segment can be put into one-to-one correspondence with real numbers. For example, given any 2 points A and B on a line, if A corresponds to the 0, then B corresponds to a positive real number, for example here 3. So the measure of this segment will be 3 inch. As you see, if we have the segment AC and we have B point between A and C, we can write AB, the part AB from the segment, plus the second part BC equal what? Equal AC, equal AC. So this is postulate 3.9, segment addition postulate. If A, B, and C are collinear, what the meaning of collinear? Means in the same straight line, like A, B, C. Then point B is between A and C, if and only if AB plus BC equals AC. For example, write the correct statements and reasons to complete the 2-column proof. Given we have QT congruent with RB. Proof QR congruent with segment TV. How to write the proof? Start from the given. QT congruent with RB. This is given. Then QT equals RB. This is definition of the congruence. Then we can write QR plus RT equals QT and RT plus TV equal RV. This is segment addition postulate. So we can write QR plus RT equals RT plus TV. Why? Substitution property of the equality, because QT equal RV. So we can remove RT from the two sides. So add the inverse of RT. So we can write QR plus RT minus RT, and in the second side, RT plus TV minus RT. This is subtraction property of equality. Remains in the first side QR and remains in the second side TV. Substitution property of equality. Then we have segment QR congruent with segment TV, definition of the congruence. The second idea, segment congruence. Theorem 3.2 properties of segment congruence. We have the 3 properties. The first property reflects property of congruence. If we have segment AB, AB segment with itself, AB segment with AB, if we have segment AB congruent with itself means segment AB congruent with segment AB. Symmetric property of the congruence. If you have AB, segment AB congruent with CB means segment CB also congruent with AB. This is the meaning of symmetric property of the congruence. And the third property here, transitive property of congruence. If we have AB equals with CD and CD equals with EF, so we can write EB equals with EF. This is the meaning of the transitive property of congruence. For example, write the correct statement and reasons to complete the two-column proof. Given R, the midpoint of QS, we have here segment QS and R in the middle, midpoint, and T is the midpoint of VS. T will be the midpoint of the VS, and we have segment QR congruent with segment VT. This is given. Prove segment RS congruent with segment TS. How to write the proof? At the first, start from the given information. R is midpoint of segment QS. T is midpoint of segment TS. As you remember, the midpoint means if you have R midpoint in the segment QS means QR equal RS, and when you have T midpoint of the segment VS means VT equal TS. So we can write segment QR congruent with segment RS and segment VT congruent with segment TS. This is the midpoint theorem. Then segment QR congruent with the segment VT. This is given. This is given. And segment QR congruent with segment TS, sorry. This is transitive property of congruence. And we have segment RS congruent with segment QR. This is symmetric property of the congruence. So we can write segment RS congruent with segment TS, transitive property of congruence. Write the correct reasons to complete the two-column proof. As you see here, in this triangle, we have given information, segment GJ congruent with segment GL, GJ congruent with GL. K is the midpoint of segment GJ. K in the middle means KJ equal KG equal KJ. H is the midpoint of segment GL, means HG equal HL. Proof segment GK congruent with segment GH. How to write the proof? Start from the given. K is the midpoint of GJ, segment GJ, and H is the midpoint of the segment GL. So the second is the midpoint theorem. We can write segment GK equals or congruent with segment KJ, and segment GH congruent with segment HL. This is the midpoint theorem. So we can write GK equals KG, and GH equals with GL. This is the definition of the congruence. So we can write GJ, the segment GJ congruent with the segment GL. This is given. So we can write GJ equals GL. This is the definition of the congruence. Then we can write GJ equals GK plus KJ. and GL equals GH plus HL. This is the segment addition postulate. Then we can write this side equal this side because GJ congruent with KJ. So GK plus KJ equals GH plus HL, substitution property of the equality. Then we know GK equal KJ. So we can substitute here the value of KJ equal the value of GK. So we can write GK plus GK and here use the same idea, GH, and substitute the value of HL, GH. Then add the like terms, GK plus GK will be 2GK, and JH plus JH equal to JH. Then divide the two sides by 2, we will get GK equal GH. This is divide by 2. Then you can use the definition of the congruence, means the segment GK congruence with the segment GH. The second idea in this lesson, proving angle relationships. At the first, we want to learn angle addition. We have some important postulate and theorem. It's very important. So the first one, Productor Postulate. Every angle has a measure that is between 0 and 180. So as you remember, we have about 5 types of the angles. We have zero angle, like this. This is 0. We have straight angle. And we have right angle. The measure of it exactly 90 degrees. And we have 360 degrees, the full angle. And if the angle between 0 is greater than 0 and less than 90, the name of this angle, acute, like this angle. And if the angle between 90 degrees and 180, this is obtuse angle, like this. So between 0 and 180, any angle between 0 and 180 has measures that is between 0 and 180. The second postulate, angle addition postulate. D is in the interim of angle ABC if and only if measure angle APT plus measure angle DBC equal measure angle ABC. The third one, we have Theorem 3.3 supplement Theorem. If two angles form a linear pair, then they are supplementary angles. Who can remember us? What's the meaning of supplementary? Supplementary angles means that the sum of the two angles equals 180. The sum of the two angles equal 180. The second theorem, 3.4, complement theorem. If the non-common sides of two adjacent angles for a right angle, then the angles are complementary angles. What is the meaning of the complementary angles? The sum of the two angles equals 90 degrees. For example, what is measure angle 3? If measure angle 1 equal 23, and we know here we have right angle 90 degree, and we know the measure of the whole angle ABC 131. So we can start the whole angle ABC equals angle 1 plus angle 2 plus angle 3. So we can write the equation: measure of angle 1 plus measure of angle 2 plus measure of angle 3 equal measure of angle ABC. This is angle addition postulate. Then substitute. The angle 1 will be 23, the angle 2 will be 90, and the angle 3 missing value, and the angle ABC will be 131. Then you can solve this equation. You can remove the constant from this side, so add the inverse. Angle C? We don't have angle here. This is an end point, not angle. Okay, this is the angle. ACB, this is the vertex of the angle. Okay. So add the inverse, negative 113 and negative 113 to the two sides. Remains here measure of angle 3 equal 131 minus 113 will be 18 degrees. In this example, as you see, we have angle 1, angle 2, angle 3. We know angle 1. Angle 1 will be 90 degree or right angle. And we know angle 2, 26. And angle 3 missing angle. What is the measure of angle 3? So as you see, the three angles in the same straight line. So the sum of the all angles will be 180. So we can write equation angle 1 plus angle 2 plus angle 3 equals 180. Why 180? Because the all angles here in the same straight line, and they have the common vertex. So the measure of angle 1 will be 90, and the measure of angle 2 will be 26. So we can write 90 plus 26 plus the measure of angle 3 equals 180. Add the like terms. 90 plus 26 will be 116 plus angle 3 equals 180. Then remove 116 from this side. You can't directly take it to the second side. So angle 3 equals 180 minus 116. So angle 3 equals 46 degrees. That was 64 degrees. So angle 3 will be 64 degrees. The second example here, what is the measure of angle 4? If measure of angle 5 will be 2x, and measure of angle 4 will be x plus 9. And as you see, 4 and 5 adjacent angles because they have common vertex and common line in the same straight line. Means the sum of the 4 and 5 will be 180. The two angles here will be supplementary angles. So we can write the equation angle 4 plus angle 5 equals 180 degree. What is the measure of angle 4? X plus 9. And what is the measure of angle 5? Will be 2x. Equal 180 degree. We want to solve this equation, so add the like terms. X plus 2x will be 3x plus 9 equals 180. Then take 9 to the second side, 3x equals 180 minus 9. So 3x equals 171. So divide the two sides by 3. X equal, we can do long division here. 17 divided by 3 will be 5. 5 times 3 will be 15. 17 minus 15 will be 2. Take 1 down. 21 divided by 3 will be 7. 7 times 3 will be 21. 0, 0. So we know now the value of x will be 57. What is the measure of angle 5? Angle 5 equal x plus 9. Now, what is the measure of angle 4? X plus 9. So what is the value of x? 57. 57 plus 9 will be 64. And what is the measure of angle 5? Will be 2x. 2x means 2 times the value of x will be 57. Two times 57 will be 114 degree. No.
57 plus 10 equals 66.
57 plus 9 equals, yes, 66. So yes, great, great, Michelle. Who has any question about this ideas? Okay. The second idea, congruent angles. We have 3 properties. This is Theorem 3.5, properties of angle congruence. Reflex property of congruence means angle 1 congruence with the same angle, with angle 1. Symmetric property of congruence means angle 1 congruence with angle 2, so angle 2 congruence with angle 1. Transitive property of congruence, if we have angle 1 congruence with angle 2 and angle 2 congruence with angle 3, so we can write directly angle 1 congruence with angle 3. Theorems. Theorem 3.6, congruent, supplements theorem. And as you see, we have the 3 angles. If angle 1 plus angle 2 equal 180, and angle 3 plus angle 2 equal 180, means angle 1 and the 3 will be congruent. So if measure of the angle 1 plus measure of the angle 2 equal 180, and if the measure of angle 2 plus the measure of angle 3 equal 180, then we can write angle 1 congruence with angle 3. And we have theorem 3.7 congruent complements theorem. Also, if we have three angles, if angle 4 plus angle 5 equal 90 means complementary, and angle 6 plus angle 5 also equal 90 means complementary, so we can write angle 4 congruent with angle 6. And theorem 3.5 vertical angles theorem. If two angles are vertical angles, like 2 and 4 vertical angles, 1 and 3 will be vertical angles. And as you remember, the vertical angles will be congruent. So it means angle 1 congruent with angle 3, and angle 2 congruent with angle 4. For example, in the figure, angle ABE and angle DBC, ABE and DBC are right angles. As you see here, ABE, we have this sign means 90 degree or right angle, and DBC also the same sign means right angle. Given angle ABE and angle DBC are right angles, proof angle ABE, this angle, congruent with EBC, with this angle. We want to prove this angle congruent with this angle. How to write the proof? Start from the given information. We have angle ABE and angle DBC are right angles. This is given. Then we want to use the definition of the right angle. The measure of angle ABE equal 90 degree and the measure of angle DBC equal 90 degree. Then we want to use the complement theorem. So angle ABD and DBE are complementary, means the sum of them will be 90 degree. And the same idea, angle DBE and EBC also are complementary because the sum of them will be 90 degree. So we want to use the complements theorem. We can write angle ABC congruent with angle ABC. Vertical angles. As you see here, angle 1 congruent with angle 2. This is given. If we have angle 1 congruent with angle 2, prove angle 3 congruent with angle 4. The proof, start from the given information, angle 1 congruent with angle 2, this is given. Then we want to use the vertical angles theorem, 2 congruent with 4 and 1 congruent with 3. So angle 1 congruent with angle 3 and angle 2 congruent with angle 4. Then we want to use the symmetric property of the congruence. 1 congruent with 3 and 2 congruent with 4 and 1 equal to. So 1 equal 3, we can write 3 equal 1 and 3 congruent with angle 2. This is transitive property of the congruence. Then we can write angle 3 congruence with angle 4 because angle 3 equal angle 2 and angle 2 equal angle 4. So we can directly write angle 4 congruent with angle 3. This is transitive property of the congruence. The last idea in this lesson, right angle theorem. Theorem 3.9. Perpendicular lines intersect to form 4 right angles. Theorem 3.10. All right angles are congruent. Theorem 3.11. Perpendicular lines form congruent adjacent angles. Theorem 3.12. If two angles are congruent and supplementary, then each angle is right angle. Theorem 3.13, if two congruent angles form a linear pair, then they are right angles. Example, in this question, we have angle 1 congruent with angle 4, angle 1 congruent with angle 4. And we want to prove angle 1 and 2 are right angles. Angle 1 and 2 are right angles. Start from the given information, angle 1 congruent with angle 4, this is given. Then use the vertical angles theorem. Angle 2 and angle 4 will be vertical angles, so will be congruent. So we can write angle 2 congruent with angle 4. Then we want to use the symmetric property of the congruence. If angle 2 congruent with angle 4, we can write angle 4 congruent with angle 2. So 1 congruent with 4 and 2 congruent with 4. So we can write 1 and 2 congruents. This is translated property of congruence. Then angle 1 and 2 are right. Why right? Want to use the theorem here. If two angles are congruent and supplementary, then each angle is a right angle. So this is our lesson for today. Who has any question about this lesson? Are all ideas clear for all? No questions? Okay. So this is our lesson for today. Thank you for your listening. Have a nice day. Have a nice weekend. See you inshallah on the next Monday. Jum'a Mubarak inshallah. Assalamu alaikum wa rahmatullahi wa barakatuh.